This video is for AP Physics problem from 1995, Mechanics, number 3. The problem states that there are two stars, A and B, in a circular orbit of radii RA and RB. And they revolve around a common center P. I'll draw this out for you, but the problem actually already has a picture. So this is RA and star A. This is RB and star B. And they follow the respective paths. RB has the outer one, RA has the inner one. And they both have the same period of revolution, T. For parts A through C, they ask us to determine expressions in RA, RB, T, and fundamental constants. So let's start with A. A asks us to determine the centripetal acceleration of star A. C of A. So the centripetal acceleration is equal to v squared over r, or angular velocity squared multiplied by r. Now, depending on which equation you choose, there's two ways to do it. So I'll show you both. So if you use v squared over r, it's r. Acceleration v is equal to 2 pi r over t. We just plug in v. So 2 pi r over t squared divided by r should give you 4 pi squared r squared over t squared over r. And if we plug in our wanted terms, so it would be 4 pi squared multiplied by RA squared divided by T squared divided by RA. And RA and RA cancel, which will give us 4 pi squared RA divided by T squared. And that's our answer. Now, using AC is equal to angular velocity multiplied by r. Angular velocity is 2 pi over t. We just plug it into the equation. So 2 pi over t squared multiplied by r will give me 4 pi squared over t squared multiplied by r. We plug in our terms. Ra divided by t squared is equal to centripetal acceleration, and it's exactly the same thing as when we use A is equal to v squared over r. Now for part B, they ask us to find the mass of MB of star B. Now we have to make the connection that the centripetal force of star A, let's draw this out. So the centripetal force of star A is due to B, A, is due to the gravitational force Fg of star B. That's why it rotates around. So we have to keep that in mind, and because of that, so the centripetal force of star A is equal to the force gravitational of star B. Force gravitational is equal. Now we need to determine what Fc is equal to Fg. Now, for centripetal, using Newton's second law, we know that any force is equal to m times a. Since it's force centripetal, it'd be v squared over r. But from the previous equation, we already know what centripetal acceleration is, which is 4 pi squared ra over t squared. That's our force centripetal of star A. And then force gravitational is the constant g, mass 1 multiplied by mass 2 over r squared. Now, I put these all together, clean it up. So Fc is equal to Fg. If Fc is equal to m times a, is equal to g m1 m2 divided by r squared. So we put in our terms mass of A multiplied by 4 pi squared Ra squared Ra divided by T squared is equal to G mass of B multiplied by mass of A divided by Ra plus Rb squared. Be careful of this radius because it's not just going to be Ra, because this equation accounts for both masses, so you have to also account for both radii. Now we simplify it. Ma will cancel. And then we are left with 4 pi squared Ra over T squared equal to GMB over Ra plus Rb squared. And since we're solving for MB, we just make everything equal to it. So then, if we're given, it should be 4 pi squared Ra multiplied by Ra plus Rb squared divided by G times T squared is equal to MB. So that is our answer right there for part B. Now for part C, they ask you for the mass of MA of star A. Now, you can make this harder on yourself and redo the whole entire thing, or you could realize that there's a symmetry to it, and that Ra and Rb, that the force centripetal of B is equal to the force gravitational of A. So, if you do that, you can do everything that we just did, but your answer should come out Ma is equal to 4 pi squared Rb multiplied by Ra plus Rb squared divided by Gt squared. And that is your answer. Now for part D. Part D asks you to determine an expression with MA, MB, RA, RB, T, and fundamental constants. Now, for part D, they ask you to find the moment of inertia of two star systems about its center of mass. So first of all, we need to determine that I, inertia, is equal to m times r squared. That's the most basic equation for inertia. Now, because they ask for two star systems, you need, and they both share the same center of mass. You need to add them. So, you would do I is equal to, if we were to think about it as in terms of our 2A, B, that it would be mass of A multiplied by the radius A squared plus mass of B multiplied by the radius B squared. The only mistake I could see someone making is thinking that the constant for inertia isn't 1, but you need to determine that for this, the constant is going to be 1. And that is our answer for part D. Now for the last part, part E, the problem asks you to find the angular momentum of the system about the center of mass. Now, angular momentum, L, is equal to I times angular velocity. Now, we know what I is. I is equal to mr squared, and the angular velocity is equal to 2 pi over t. Now they want us to find angular momentum of the system, and the system has 2 stars. So we need to account for both. So we can use whatever we had in part D here, and then whatever we had in, where did we use? In part A for here. Now, the moment of inertia, if you recall, is MARA squared plus MBRB squared multiplied by 2 pi t. It's the same thing because the t given is the same. And that is your answer. That is the angular momentum. There is another way you could do this, but that's using the equation L is equal to mvr. I'll do it really quickly here. So L is equal to mvr. So then for each star, we have ma multiplied. Since we know that v is equal to 2 pi r over t, so then it will be 2 pi ra over t multiplied by ra plus mb multiplied by 2 pi rb over t. Alright. Oh, that's supposed to be b. So then if we do some nice cancel. Oh, shoot. Must be going crazy. My bad. Okay, nothing cancels. But common constants pulled out. So then L equal MA RA squared plus MB RB squared. I'll give you L, and it's the same exact answer. So really quickly, the answers to all of them So for part A, the answer should be 4 pi squared RA over T squared. For B and C, well, I'll do them separately. MB is equal to 4 pi squared RA multiplied by RA plus RB squared over GT squared. And for C, MA is equal to 4 pi squared RB multiplied by RA plus RB squared over GT squared. D is equal to I is equal to MA RA squared plus MB RB squared. And E is equal to 2 pi T multiplied by, I'm just going to put down I because I don't have a lot of room. I is whatever you got for D. So those are all the answers, and